In today's class, we are going to see the topic functions. First, we will start off with the basic definition. Definition of a function. So, what is a function? A relation f between two non-empty sets x and y is a function from x to y. So, f is called as a function from x to y under a condition for every x in x there exists only one y in y. So, this represents the definition of a function. For each x in x, there must be only one y in y, and it is represented as f is equals to x comma y such that for all x in x, there exists y in y. Next, a function from f from x to y can be written as f is a mapping from x to y. This is called as a function f from x to y. So, when we write the examples, we can understand definition of a function clearly. Now, we are going to see the example of a definition more clearly. For seeing the definition of a function, we will use an arrow diagram to understand more clearly. So, I am taking this as a first example. This will represent it as x and this will represent it as a y. It is a function from x to y, and x has a set of elements a, b, c, and y has a set of elements p, q, r. Now, a is mapped to p, b is mapped to q, c is mapped to r. Whether it is a function or not, yes, it is a function. How do I say this as a function is, according to the definition of a function, for every x in x, there exists only one y in y. See, for a, we have only one y, and for an element in x, b, we have only one y, and for an element in x, c, we have only one y. Therefore, this is called as a function. We draw a arrow diagram and we checked with the definition of a function. It satisfies the definition of a function. Therefore, we call this arrow diagram as a function. We will do some more examples under function. We will see few more examples for a function. I am considering this example using an arrow diagram. So, two sets x and y, and f is a mapping from x to y, x as a set of elements a and b, and y as a set of elements x, y, z. See, now a is mapped to x, b is mapped to y, and b is also mapped to z. Now, we will check with the definition of a function. What does the definition of a function gives us is, for every x in x, there must exist only one y in y. For x in x, there is only one y. If you see b, this is an element in x, whereas it has mapped to two elements in y, which does not satisfy the definition of a function, because b has two images, b has y as an image and b has z as an image. Therefore, this function is not a function. It is not a function. We will consider one more example to test a function. This is the set x and this is set y, and f is a function from x to y. 1 is mapped to m, 2 is mapped to n, 3 is also mapped to n. Whether this is a function, we will check it. How to check it? We have to use the definition of a function to check whether it is a function or not. What is definition of a function? For every x in x, there must exist only one y in y. Okay, so let us take the element from the set x. It has only one y. Let us take 2, it has only 1y. Let us take 3, it has only 1y. Therefore, this is also a function. Two elements in x may be mapped to the same element in y. What am I saying is, one element from x will not have the same image in y. So, this is the difference between the previous example and the example we have done now. So, with this example, we will see few more points in a function. So, first point is, when is a function, we will consider a function f is a mapping from x to y. Then, first point is, the set x is called domain. The set x is called domain, which means the elements in the set x is called as a domain. So, domain is represented as, with this example I am saying, domain for this example is 1, 2, 3. This is the first point. And the second point is, the set y is called codomain. The set y is called codomain. What does it mean? The elements in the set y is called as a codomain. So, codomain for this example is written as, codomain is equals to M, P, N. And the third point is, if f of a equals to b, f of a equals to b is nothing but, I will tell you how to write this f of a equals to b for this function. So, f as a mapping from x to y. For first point I will write, this can be written in such a format, f of 1 is equals to m. So, this is a general format, f of a equals to b. In a function, f of 1 is equals to m. In this represents the value of x and this represents the element in a set y. So, in general, if f of a is equals to b, where b is called as image of a, b is called as image of a, then what does it mean? M is called as the image of 1. So, this is one point. And the another point is, this A is called as pre-image of B. Pre-image of B. What does it mean? 1 is called as a pre-image of M. I will repeat once again. So, according to this statement, M is called as the image of 1 and 1 is called as the pre-image of M. So, this is over. And the fourth point in this is, the set of all images of the elements of x under F is called as range. So, we will write a range for this given problem. So, what is range? The set of all images of the elements of x under F is called as range. So, what is the images? These are all the images, and whichever as images only will be considered as a range. See, M is a image, N is a image, where P is not mapped from any element in X. Therefore, we will not consider P. Range represents only M, N in this example. When it is domain, the set X is called as domain. When it is codomain, the set Y is called as codomain, and if it is range, the images only are called as range. This is example 1.6. We are given with two set of elements, x represents 1, 2, 3, 4 and y 2, 4, 6, 8, 10, and we are given with the set of ordered pairs as a relation R. What we have to do now is, we have to check whether this R is a function, and we have to write domain, codomain and range for this function. So, let us check whether this is a function by using an arrow diagram. So, in an arrow diagram, this is set x and this is set y. by the relation R. In X set it is given as 1, 2, 3, 4. In Y set it is given as 2, 4, 6, 8, 10, and we are given with the relation to test whether it is a relation function or. So, in the given relation 1 is mapped to 2. So, 1 is mapped to 2 and 2 is mapped to 4, then 3 is mapped to 6, 4 is mapped to 8. So, according to the definition of a function, for every x in X there is only one y. Therefore, this is a function. It is a function. So, first we have found out it is a function. Second thing what we have to write is, we have to write domain of this function. As we already know what is domain, the elements in the set X is called as domain. Therefore, domain is equals to 1, 2, 3, 4. Next, we have to write codomain. What is codomain? We already read the codomain is nothing but the set Y. The set Y represents the set of elements as 2, 4, 6, 8, 10. Next, we have to write the range. Range is equals to, range is nothing but we have to write only the set of all images. 2 here is the image, 4 here is the image, 6 here is the image, 8 here is the image. 10 doesn't have any image. So, we will write the value of range as 2, 4, 6 and 8. In example 1.7 it is given as a relation f is a mapping from x to y is defined by f of x is equals to x square minus 2. So, this is the relation given to us where this represents f of x is equals to y in general, and we are given with a set of values for x. Y must be a real number, that is the given condition in this problem. Two things we have to do in this problem. The first thing is we have to list the elements of f and we have to check whether f is a function. We will do one by one. First, we are given with f of x is equals to x square minus 2 and we are given with set of values for x. We will substitute the values of x one by one in this equation. We will find out the value of y. Then we will do it in an arrow diagram, check whether f is a function or not. So, first we have taken the condition f of x is equals to x square minus 2. First, when x value is minus 2. So, when x value is minus 2, we have to substitute in this equation. In place of x, we have to substitute minus 2. So, f of minus 2, right hand side also in place of x, we have to substitute minus 2 whole square minus 2. Minus 2 square means it is minus 2 into minus 2 will become plus 4 minus 2. So, 4 minus 2 it is 2. When x is equals to minus 2, we got the value of y as 2 and it can be written as minus 2 comma 2. Next is, we will take the value of x as minus 1. When x is equals to minus 1, we will substitute in the same equation minus 1 in place of x. Therefore, f of minus 1 is equals to minus 1 squared minus 2. Minus 1 into minus 1 will become plus 1 minus 2, which will give us plus 1 minus 2 is minus 1. Therefore, when we took x value as minus 1, we got the y value as also minus 1 and this can be represented as minus 1 comma 1. So, we found out for two set of values. Next, moving on to the third value, when x is equals to 0, we have to substitute it in the same equation. In place of x is 0. So, f of 0 equals to 0, 0 square minus 2. 0 square is 0 minus 2, it is minus 2. Therefore, when x is equals to 0, y is equals to minus 2 and it can be written as 0 comma minus 2. Then checking for the last value of x, when x is equals to 3, substituting it in the same relation, f of 3 equals to 3 square minus 2. So, 3 square is 9 minus 2, 7. When x is equals to 3, y value is 7. So, we got 4 set of ordered pairs. We will complete these two subdivisions. First subdivision, what we have to do is we have to list the elements of f. So, these are all the elements of f according to the given equation. Okay. So, f can be expressed as minus 2 comma 2, minus 1 comma minus 1, 0 comma minus 2, 3 comma 7. So, first option is over. Next, second option, we have to check whether f is a function. We will take the help of an arrow diagram to check whether it is a function. So, this will represent it as x and this will represent it as y. It is a function f. So, x has the values minus 2, minus 1, 0, 3 and y has the set of values 2, minus 1, minus 2, 7. So, minus 2 is mapped to 2, minus 1 is mapped to minus 1, 0 is mapped to minus 2, 3 is mapped to 7. So, hence it is a function, because by the definition of a function, for every x in x there is only one y, which means the image is unique. Therefore, it is a function. Next is example 1.8. If x is equals to minus 5, 1, 3, 4, y equals to a, b, c, set of values x and y is given, then which of the following relations are functions from x to y? So, we are given with three relations and we have to check whether these three are functions from x to y. We will do it one by one. So, first R1, we will get the help of an arrow diagram to check whether it is a function or not. So, x is given as the set of values, y is given as the set of values. Now, we are going to do it for R1. X is minus 5, 1, 3, 4 and y is a, b, c. In relation 1, minus 5 is mapped to a. Next 1 is mapped to a. Next 3 is mapped to b. Now, we have to check whether this is a function or not. According to the definition of a function itself, we can do it. This is not a function. Why this is not a function is, the domain 4 does not have any image, which means the domain, all the domains in the set x must have an image in y, but whereas 4 does not have an image in y. Therefore, this is not a function, because 4 in x does not have an image in y. So, R1 is completed. Next, we will move on to second option, R2. The same format we will follow to check whether it is a function or not. X, y, R2 and x is minus 5, 1, 3, 4, y is a, b, c, minus 5 is mapped to b, 1 is mapped to b, 3 is mapped to a, 4 is mapped to c. Whether this is a function? Yes, it is a function, because for every x in x there is only one y in y, which means 5 is mapped to b, 1 is mapped to b. It may have in such a way, 3 is mapped to a, 4 is mapped to c. Therefore, R2 is a function. So, example 1.9, given f of x is equals to 2x minus x square, we have to find three subdivisions. First is f of 1, second is f of x plus 1 and the third one is f of x plus f of 1. We will go one by one. In this problem, the given relation is f of x is equals to 2x minus x square. So, with the help of this relation only we can find all the three subdivisions. First subdivision is f of 1. F of 1 means in place of x we have to substitute the value as 1. So, substituting this we will consider it as first equation. In first equation we will substitute the value of x as 1. So, f of 1 is equals to 2 into 1 minus 1 square. So, 2 into 1 is 2 minus 1. Therefore, f of 1 value equals to 2 minus 1, 1. We have found out the first subdivision. Second subdivision is we have to find out f of x plus 1. The same method we have to follow. We have to substitute x value as x plus 1 because in this problem in the place of x we are given it's x plus 1. Substitute x equals to x plus 1 in equation 1. So if I do so, what will I get? F of x plus 1 equals to 2 into x plus 1 minus, in place of x we have to substitute x plus 1, it will become x plus 1 whole square. Next what we have to do, this we can simply multiply. So 2 into x will become 2x, 2 into 1 2. In this portion what we have to do is we have to expand this using the formula a plus b whole square. It is a well known formula. A plus b whole square is equals to a square plus 2ab plus b square. For this portion the value of a is x and for value of b is 1. We will substitute in this. What will we get? A square means x square plus 2 into a value is x and b value is 1, 2 into x into 1 plus b square is 1 square, it will become 1. Therefore, x square plus 2x plus 1. So, x plus 1 whole square is an expansion, x square plus 2x plus 1. In the next step, what we have to do is we have to remove the brackets from this. So, 2x plus 2 minus into x square minus x square, minus into plus will become minus 2x, minus into plus will become minus 1. In the next step, plus 2x and minus 2x will get cancelled. Writing it this in an order, it will give us minus x square plus 2 minus 1 will become plus 1. So, f of x plus 1 is equals to x square minus x square plus 1. Moving on to the third subdivision. Third subdivision, what we have to find out is we have to find out f of x plus f of 1. We already know the value of f of x. It is directly given in the question as 2x minus x square. F of 1 also we have already found out. F of 1 is equals to 1. So, we can directly substitute this f of x value in this place and f of 1 value in this place and we can directly simplify. So, what is f of x? It is 2x minus x squared plus what is f of 1? We got the value as 1. So, rearranging it this in powers of x, we will get it as minus x square plus 2x plus 1.